Hey, everyone, get this. Remember RNNs?
RNNs.
Yeah, RNNs. Kind of a blast from the past in the AI world,
Oh,
right?
yeah.
Turns out they might be more powerful than we thought, especially for running complex stuff like language models, even on something as simple as your phone.
Really?
We're taking a deep dive today into some really cool research asking the question, were RNNs all we needed?
It's pretty exciting. You see, for a while, RNNs were like the thing for anything involving sequences of data, like understanding language.
Right.
But then came the era of transformers, which could process information much faster.
Okay.
This research might just signal the comeback of the RNN.
So why did RNNs fall behind in the first place?
Hmm.
The research mentions this thing called backpropagation through time, or BPTT.
Right.
And forgive me, but what exactly is that?
Well, imagine reading a whole book just to understand the meaning of the last chapter.
Okay.
That's kind of what traditional RNNs were doing with BPTT. They had to reanalyze the entire sequence of data, even for small updates,
Wow.
which was really slow and inefficient.
So it's kind of like if you had to reread an entire email thread every time you got a new reply
Yeah.
just to understand the latest message?
Yeah, exactly.
Exactly. No wonder they were slow.
Yeah.
And that's where these minimalist RNNs, the minGRUs and minLSTMs, come in.
Exactly. You see, LSTMs and GRUs were two popular types of RNNs. They had these special mechanisms, think of them like filters, that help them remember important information in those long sequences. But even they were held back by BPTT.
Okay, so how did they make them minimalist?
Minimalist.
Did they just, like, hit the delete key on half the code?
It's a bit more elegant than that, but essentially yes.
Okay.
They found that LSTMs and GRUs had some unnecessary complexities. By simplifying the math and removing these dependencies, these minGRUs and minLSTMs could suddenly train in parallel.
Hold on, parallel processing. That rings a bell.
Yeah,
Isn't that what made transformers so fast in the first place?
you got it. It's like instead of one person reading that whole book, you can now have a whole team reading different chapters at the same time.
Right.
That's a game changer in terms of speed.
So they found a way to make these RNNs train faster.
Right.
That's awesome. But the big question is,
Yeah.
do these minimalist models actually hold up in the real world?
That's what's so cool about this research. They didn't just stop at theory.
Okay.
They really put these min-RNNs to the test. They ran them against some of the most advanced AI models out there, even those powerful transformers,
Yeah.
on three key tasks:
Okay.
selective copying,
Okay.
reinforcement learning,
Right.
and language modeling.
Okay, let's break those down. First
Okay.
up, selective copying.
Uh-huh.
What's that all about?
Imagine trying to pick out specific information from a huge, messy data dump.
Okay.
Like finding all the mentions of a certain topic in a massive email chain.
Right.
Selective copying tests a model's ability to focus on the important stuff
Wow.
and filter out the noise.
And how did the minRNNs do? Were they able to cut through the clutter?
They totally aced it.
Wow.
This kind of task can really trip up even the more complex AI models out there.
Yeah.
But these minGRUs and minLSTMs consistently zeroed in on the right information. It was impressive to see.
Okay, so they've got that laser focus.
Right.
What about the second task? Reinforcement learning.
Okay.
What is that exactly?
Reinforcement learning, or RL,
Right.
is how we teach AI to learn through trial and error,
Okay.
like how you might train a dog with treats,
Right.
or even how we learn to ride a bike.
Right.
It's all about learning from mistakes and getting better over time.
Right. So for AI, we're talking about things like
Yeah,
teaching a robot to navigate a maze,
exactly.
or maybe even play a video game.
Yeah,
Right.
got it.
Okay.
In this case, the researchers tested the minRNNs on a bunch of RL tasks that involved robotic movement.
Okay.
And guess what? They outperformed most of the other models,
Wow.
even some that were considered much fancier.
So not only can they handle these complex language tasks,
Right?
but they can also wrangle robots.
It's true.
These minRNNs are starting to sound like little overachievers.
Yeah.
What about the last task?
Okay.
Language modeling.
Language modeling.
I think I need a refresher on what that one is all about.
Language modeling is all about teaching AI to understand and generate human-like text.
Okay.
Think about how your phone can predict the next word you're going to type, or those AI writing tools that seem to be everywhere these days.
Right.
That's all thanks to language modeling.
Okay, that's starting to ring a bell.
Yeah.
So for this test,
Yeah.
were the minRNNs still able to keep up with those more complex models?
For this particular task, the playing field was pretty level.
Okay.
The minRNNs were just as good as the more powerful transformer models at predicting the next character in a sequence of text.
Okay.
But here's where it gets interesting.
Okay.
They needed significantly less training time
Wow.
and computing power
Right.
to achieve those same results.
So even for a task like language modeling, where transformers are considered like the top dog,
Right.
these mid-RNNs were just as effective,
Yeah.
but way more efficient.
Yeah.
That's huge. Does this mean we should all just ditch the complex models and go back to basics?
Right.
Is simplicity the key to, like, unlocking the next generation of AI?
It's tempting to think so, isn't it?
Yeah.
And while this research is super exciting,
Yeah.
it's probably a little too early to declare, the comeback of the RNN.
Right.
What's really important here is the bigger picture.
I'm all ears. What's the takeaway here?
This research challenges us to really rethink our assumptions about AI.
Okay.
Do we always need bigger, more complex models to solve problems?
Okay.
Or can we sometimes achieve better results and use less computing power
Yeah.
with simpler, more elegant solutions?
It's like that saying, work smarter, not harder. But for AI,
Right.
maybe we've been so focused on pushing the limits of complexity that we've overlooked the power of simplicity.
Exactly. And think about the practical implications here.
Yeah.
If we can get the same results with less computing power,
Right.
we could start running these advanced AI models on devices we use every day.
Oh, wow.
No more relying on huge data centers or constant internet connections.
You're saying we could have powerful AI running locally?
Yes.
On our phones,
Exactly.
tablets, even smartwatches.
Absolutely.
That opens up a whole world of possibilities.
Absolutely. Imagine sophisticated AI assistants,
Right.
real-time language translation,
Wow.
personalized education tools,
Yeah.
all running seamlessly on your devices.
Wow.
This research could make AI more accessible to everyone.
This has been an incredible deep dive.
It has.
I have to say, I started this deep dive thinking RNNs were yesterday's news.
Right.
But after unpacking this research, it seems like they have a lot to offer.
Yeah.
Maybe even more than we ever realized.
It just goes to show that sometimes the most groundbreaking discoveries come from revisiting the fundamentals with fresh eyes.
It's a good reminder for us all.
Yeah.
That sometimes the most elegant solution is also the simplest.
It's true.
If you're as intrigued by this research as we are, you can find a link to the full paper, Were RNNs All We Needed?, in the show notes.
Yes.
Until next time, keep asking questions and never underestimate the power of a good deep dive.
That's right.